All right, here we are on the third video of section 7.3, and we're still looking at the product right now. And the reason why we're doing this is because you want to make sure that you are remembering all your rules for factoring, and you're looking to see how you can apply them and really make sure you're doing everything possible to try to cancel common factors. That's really the key to calculating the products, is making sure that you factor these down as much as possible so that you can cancel as many terms. Now, one thing you see right here is that you've got a rational expression, so an expression that's being expressed as a quotient, so as a fraction. And here you have just a polynomial. Now, don't let this fool you. You can write anything as a fraction. Just remember that any expression, even if it doesn't have a fraction bar and it's not written as a quotient, can always be written as a fraction with a denominator of 1. Because anything divided by 1 is just whatever the numerator is. So this will help you with your multiplication because you can see all of the numerators and denominators that you're multiplying together. Even though that this doesn't change the value, it still allows you to see explicitly all the terms that you're multiplying together. So a lot of people find this really helpful to write this 1 down here just so you can see what you're multiplying. I recommend doing it. I still do it when I'm multiplying together, and I recommend that you do too, especially when you're in the early stages of learning this. So the next step here is we're just going to go ahead and see what we can do about trying to factor things. Now, if we look at x squared plus 3x plus 9, well, first let's see, x plus 2 we can't factor. X squared plus 3x plus 9, I don't think we can factor that. That's an expression that we can't factor into two integer binomials. Now, if we look at the bottom, x cubed minus 27, this right here should jump out at you as the difference of cubes. Now, if you remember your difference of cubes, if you have a cubed minus b cubed, that equals, we get right here, we get a minus b. If you remember, we did this, I believe it was in chapter 4 or chapter 5, so you have to remember back a little bit, and that equals a squared plus, I think it is ab, and minus b squared. So this is one where, actually plus b squared, I'm sorry, my apologies. This is one where you have to remember your rule. Now, if you see something like this, if you see like two cubes being, if you see them with only two terms in a binomial, you should try to look this up if you can't remember. The sum and difference of cubes, those, you know that they can always be factored. So you want to make sure that you take the time to look those up. If you can't remember, look in your book, look on the internet. So you end up getting, you can factor it out to this. So this would end up being, this is, our a term is x, and so this is x cubed, and our b term is just 3, because 27 is just 3 to the third power. So when we go ahead and write this out, we plug this in here, we're going to get x minus 3 times a squared, x squared, plus ab, so that's 3 times x, plus b squared is just 3 squared is 9. So we go ahead and we write this out, and by factoring, we end up now with some common terms that we can take out. So we've got x plus 2 times x squared plus 3x plus 9 on top, then x minus 3 times x squared plus 3x plus 9 on bottom. Now, conveniently, we can go ahead and cancel these two trinomials out. So just by remembering what your difference of cubes was that you see right here, you ended up being able to cancel out an entire trinomial from the numerator and denominator. And what we get is just x plus 2 times x minus 3. So this works out perfect. If you remember, if we look at our original function, you know that x can't equal 3 because x cubed minus 27 is 3, or 0. And if you look at our new one, x still can't equal 3. So nothing changed. There's no values that we can't be. It's 3 in our original and 3 in our final. So we've got x cannot equal 3 for both of those. What I want you to do to test this out, I want you to go to extra example 4. I want you to follow the exact same steps that I just went through right here. And go ahead and multiply this out. I want you to write down in the question box your final answer. And I want you to write out if there's any values that x cannot equal. Make sure you write those down for me. All right, what we're going to do is move on to the next one. We've got teaching example 5. And what we're going to do is we're going to look at a division problem. So dividing a rational expression. Now, I think what you're going to see is dividing rational expressions is actually really, really easy. The reason why is this is really just a multiplication problem. So here's one of our properties. Our property of division is that if you've got two fractions, so let's say a over b divided by c over d. You've already learned this if you remember back to your just basic division of fractions. If you take, if you're dividing by a fraction, that's the same as multiplying by the reciprocal. So a over b divided by c over d is actually a over b times d over c. You'll see right here that d is the reciprocal. D and c are just flipped. So really, a division problem is just a multiplication problem. All you're doing is flipping your second term and doing multiplication. So if you look right here, 7 over x plus 1 divided by x plus 2 over 2x minus 3, you just go ahead and you flip your second fraction, and now it becomes times 2x minus 3 over x plus 2. And then you just do the same things as we've just been practicing. So remember, when you're dividing by a fraction, all you do is flip your second term. One of my students last year told me something interesting. So let's just say we're doing this problem right here. What she said is a way to remember this is by remembering the term copy dot flip. So copy dot flip means you copy your first term down, so 7 over x plus 1. You write a dot in the middle now, and you remember dot means multiplication, and then you flip your second fraction. So 2x minus 3 over x plus 2. So that's all you're doing is copy the first term, write a dot, and then flip your second term. And that's it. Copy dot flip. Copy dot flip. Say it a few times and I guarantee you it'll get stuck in your head. So let's look at this example right here so we can go ahead and give it a try. So let's see, we are doing 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. Well, what we want to do is we're going to take it, so we've got our original function. Let's go ahead and just say copy dot flip. So what we do is we copy our first fraction, we dot, which means multiplication, then we flip. So x squared minus 11x plus 30 goes on top, x squared minus 6x goes on bottom. So we just copy dot flip, and now we have our multiplication problem. Now all the steps are exactly the same. Okay, all you do is you factor each numerator and each denominator. So what we get is 7x over, we factor out a 2, we get x minus 5. So 2x minus 10 with a GCF of 2 taken out is x minus 5. Our top numerator on our second function, which we've flipped now, is x minus 5 times x minus 6. And our denominator goes to x times x minus 6. You'll see we've got some things we can cancel out right here. X minus 5, x minus 5. Remember, you can take these out. They don't have to be on the same term. You can take from one numerator and one denominator. Our x minus 6 can cancel out for each one. We can go ahead and we've got an x here and an x here. So really all we're left with is just our coefficients, 7 over 2. So when we go ahead and work through it, you'll see 7 over 2. And again, the values that we can't be, if you go back here, we can't be 5, we can't be 0, and we can't be 6. So our x values are limited to that. Okay, good job on that one. What I want you to do now is try the exact same thing with dividing these two fractions. Remember, copy.flip is your friend on this one. Give it a shot. Write your answer, so what your final term is, in the question box. Also, write down what values x cannot be.